Alright, guys, completing the square is a concept, a different form. I should just say it's a different form of solving these particular equations than factoring. Some of the equations that you work with are easily factorable, and if they're not easily factorable, then we have completing the square. Alright, so the ones we're going to be doing are not ones that you could easily factor. But this method isn't too terribly complicated. You'll get the hang of it here in a little bit. But I want you to remember something. Whenever you're completing the square, you're going to need to use this b squared over 4a. This is what's going to be added to both sides of the equation as we go through the process of completing the square. Now, if you go to the resource room, you might see them do something slightly different. But I want you to trust me on this one because I'm actually trying to prevent you from making mistakes. I've seen too many kids do it the same way year after year after year, the same way that the book does it. And if you ignore me on this one, there's chances on certain problems for making mistakes, and I want you to avoid them. So if you stick with me, guys, on this b squared over 4a, it will be much easier for you. Now, I actually like example 2 to be my first one instead of example 1 because in the book, and I'll show you why. Because I need you to get the idea of what it means to find a term which would complete the square. If you needed to add a number to this expression so that it would become a perfect square, and I'll show you what I mean by that, you're going to use b squared over 4 times a. We could see that the a value is 1 and the b value is negative 8. So this would be 64 over 4. We know that better as 16. So 16 would go in the blank. Now this is a perfect square. We call it a perfect square trinomial. Trinomial meaning it has 3 terms. Now, what is it the perfect square of? What times itself will give me that? Well, if I asked you to factor this, you would need to come up with factors of 16 that add up to 8. Obviously, both of them would have to be negative. And you would get x minus 4 and x minus 4. But instead of writing x minus 4 twice, I'm going to write it once and put an exponent up here so that you know that it's being multiplied times itself. And if you were to actually go through x minus 4 times x minus 4, you would get right to back to where we started. That's the idea of completing the square, is using b squared over 4a to find out what you're going to be adding. Okay? Now, so some of you are probably not going to recognize this, but if you took b squared over 4a, what would you get? Well, that'd be 10 squared over 4 times 1. That's 100, right? Here, I'll do it off to the side here. 10 squared over 4 times 1, that's 100 over 4, which is 25. If it equals this number, then you already had a perfect square. That's why I didn't quite like example 1, because example 1, they start off with a perfect square. That doesn't kind of give you the flavor for what it means to complete the square. In a lot of these problems, you might not recognize that it is a perfect square, so the first thing you're going to do is you're going to subtract 25 from both sides, giving you x squared plus 10x plus blank equals, see, 36 minus 25 is 11 plus blank. This is what a lot of people would do, okay, before they realized that they actually had a perfect square. Because they would do the b squared over 4a, get 25, and then they would add it to both sides. Well, I hope you realize that this is going to take me right back to the 36 that I had before. Now, my question to you is, what would that factor into? What times itself gives me this? Well, you take the square root of this and half of that number. The square root of that and half of that number. Now, to get rid of a square, I'm obviously going to take a square root. That would give me x plus 5 equals plus and minus 6, right? Remember, we're in a solving situation, And when you're solving and you take a square root, it's a possibility that you could get the positive or the negative. Now, if I were to subtract 5 from both sides, if you had a 6 and you took away a 5, right? Then x could be 6 minus 5 would be 1, or negative 6 minus 5 would be negative 11. Those are the two solutions to this. Now you might say to yourself, well, why did I go through the process of completing the square if these were easy numbers like that? Well, those were, but other ones will not be. Okay, and I will refer to completing the square as CTS because it's just easier to write time and time and time again. Alright, so let's go through this process of completing the square. First thing I'm going to do is I'm going to subtract 5 to the other side, giving me x squared minus 12x. I hope you notice that I am leaving some space on both sides of the equation because I know in my mind that I'm going to be adding b squared over 4a. So if I can add that b squared over 4a to both sides, so b squared over 4 times a. That's 144 over 4. Oh, what do we got there? 3 and a 2, 36. So I'm going to be adding 36 to both sides of the equation. On this side, obviously, I have 31. And on this side, I need to factor it into something that's times itself. So we take the square root of x squared and half of negative 12, which happens to be negative 6. Now, when you take the square root of both sides, you're going to notice you're not going to get nice numbers on the other side. You're going to get positive and negative square root 31. Do not try to come up with some nasty weird decimal. Leave it alone. And then, of course, you can add 6 to both sides. And so my answers are going to be 6 plus and minus radical 31. Okay? That is, obviously my two answers are 6 plus radical 31 or 6 minus radical 31. But in order to save space and trouble, we just write it together with a plus and a minus in the middle. Solve by completing the square. Okay, so same idea here. We're going to subtract 36 to the other side, moving it over. Giving myself some space here. I'm going to leave some room. Let's see. B squared over 4 times A, 64 over 4. Yeah, that's that 16, right? That's going to go there. And it's going to go over here. So if I factor this, right, I've got x, and then half of that number minus 4. Then over on the other side, I've got a negative 20. Same old as I was doing before. Take the square root on both sides. Except on this particular one, remember, when there's a negative on the inside, that's going to do something different, right? The square root of a negative 1, right? I remember that. Hopefully you do too from section 5-6 because that causes I to be in your problem. Remember, we're going to split this up into the square root of negative 4 and the square root of 5. Perfect square that goes into 20 is 4. The negative comes with it, and that gives me plus or minus 2i radical 5 equals x minus 4. Last thing we need to do is add the 4 to the other side. And so we end up with 4 plus or minus 2i radical 5. I can't add those together because one's a real number, one's an imaginary number, so I'm going to leave that complex number alone. Example 5 is one that we might have to practice a little bit to make sure you guys understand it, because this is where the b squared over 4a trick really comes in to help you. I am going to take this term and move it to the other side. So I've got 3x squared minus 12x. Oops. What am I doing? Plus something equals negative 8 plus something. I need to leave myself a little bit of space here. Okay, because I'm going to try that b squared over 4 times a trick, and that's going to give me 144 over 12, which is 12. So that's going to go on both sides of the equation. Now, here's where it's a little bit different. These three terms have something in common, a GCF. I need you to remove it. I need you to pull it out. It happens to be this number right here, and it doesn't matter really whether it was that number or not. You still have to pull that number out. So don't even worry about the fact that it's a GCF. This number right here must be pulled out, leaving me x squared minus 4x plus 4. And over here, this stuff right here is 4. Now, I see that this is a perfect square, so I am going to factor it down. When I factor it down, I have x, right? And half of this number. And if you were to go backwards and FOIL it, you go right back to that thing, but that's not what we want to do. We're continuing to solve this equation by dividing out the 3. Now, 4/3 isn't it's not going to be a really super nice number. And we're going to have to take the square root like we've done before. That's going to give me x minus 2. In this case, I've got plus and minus 2 over the square root of 3. Because I know the square root of 4 is 2. Square root of 3, I don't really know that much. Okay. From geometry, from your days in geometry, I hope you remember how to rationalize denominators, because we want to get that into a that denominator rationalized, I should say. And then we're going to add the 2 to the other side. So we're going to have a 2 plus or minus 2 radical 3 over 3. And I can't really add those together. One's irrational, one's rational. Not something I can really deal with. So my x values, I should say, are those 2 right there. We will have to practice that one a little bit more because of this idea of pulling out that factor that's in front before the rest of the process continues. Alright, now there's a slightly different form that I'm going to use on these types of questions. Rewrite in Vertex Form by completing the square. I know some of you are going to look at this problem and go, whoa, I could just do the opposite of b over 2a and plug it in and find the vertex right away. We already know the a value is 1 in this case. I do understand your thinking there, but I want to show you how you can use the idea of completing the square, and you will have to use the idea of completing the square for this process or for this problem. So just because you have a different way to check it doesn't mean that you still don't need to learn this method. So this one's going to look a little bit different. Instead of taking the 2 to the other side of the equation, I'm actually going to put the plus 2. I know it looks weird. I kind of separated it out to the right, which kind of looks bizarre. So what I want you to do is a little bit different. We're going to use that b squared over 4a trick, and we're going to add it. Okay, so this would be 6 squared over 4 times 1. 36 over 4 is 9. And on the same side of the equation, we are going to subtract the same number. Now, I know you're looking at me right now, listening to this, going, what in the world would you want to do that for? Why would you want to add the number 9 and subtract it from the same side? Because last time I checked, 9 minus 9 is 0, so you pretty much just added 0 to the right side of the equation, which doesn't look like it made any difference in the world. Well, it did actually, so I want you to realize all I'm doing is rewriting this into a different form. I need you to look at this as 2 separate things. One, a perfect square. And if I ask you to factor that, something times itself, you have x plus, right? X plus half of 6 would be 3. X plus 3. And then out here on the end, we have minus 7. Dun, 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 dun. We have vertex form. So it's actually kind of a slick way to do it, because you can easily see the vertex. In fact, I don't know, it's probably easier than finding HK, you know, by plugging, you know, I think it's probably easier than the other way. Okay, so here's another one we can practice with. It's a little bit more complicated. So we have y equals 2x squared minus 10x, and we'll put the plus 9 over here. And we'll do the b squared over 4 times a, right? That's 100 I wasn't very kind to you. 100 over 8. Okay, now that reduces to what? 50 over 25 over 2. So obviously I was not very kind to you. I'm adding 25 over 2 and I'm subtracting 25 over 2. Obviously that means I've added 0. So we're going to think of these as two separate things. Now, out of these three, now that idea of GCF has kind of got tossed out the window here. We are actually going to pull out this number right here, 2. And if I divide that by 2, then I'm left with x squared. And if I divide that by 2, I'm left with negative 5x. And if I divide that by 2, well, division, let me write this over here on the side here, division is the same as multiplication by the reciprocal. So dividing by 2 is the same thing as multiplying by a half. So that's 25 over 4. I know we got some decimal fans out there that want to go 6 1/4. That does work. It is true, 6 1/4. So if you like, you know, 12 1/2 right here and 6.25 there, that does work. Over here on the side, if you're really in fact, I can even write it like that if that would make it easier for you. I guess I just didn't think about it, but 6 1/4. This is negative 12.5 plus 9, so that's negative 3.5. And then I need to collapse this down. Y equals 2 something squared minus 3 1/2. Well, remember, it's the square root and half of this number. There it is, vertex form. So that one was a little bit different because I had to pull out the 2 before I figured out the rest of it, before I did the breaking down of the perfect square and so forth. Okay, see you in class.